Hi everyone, so this is a revision for the test that's going to happen on the week of January 9th. The first question, an airplane is flying horizontally, that's a very important word guys, horizontally, at a steady speed in a straight line. The figure shows 3 of the 4 forces acting on it. The first question says, in order to fly horizontally at a steady speed, which 2 forces, guys, horizontally, okay? Which 2 forces that are shown on the airplane must be equal. So for it to fly with a steady, constant speed, the acceleration has to be 0, which means that the forces are balanced. And therefore, this force here, the engine thrust, needs to balance the air friction. So the 2 forces are the engine thrust, and the air friction. Then the second one, in order to fly horizontally in a straight line, there must be a 4th force acting on the plane. Draw an arrow to represent this force. Well, if it is flying horizontally, there must be a upwards force here that will balance the weight so that it will not move vertically. Okay, so the arrow would be this arrow over here. B, the airplane in the figure flies an outward journey from Budapest in Hungary to Palermo in Italy. It takes 2.75 hours, and the distance is this. It's asking us to calculate the average speed. So the average speed is going to be the distance. And note the unit, guys, okay? The unit is kilometers per hour. So the average speed is going to be the distance divided by the time. We can represent average speed like this, V with a bar on top. And the distance is 2,200 kilometers. The time is 2.75 hours. If you use a calculator, you're going to find that this average speed is 800 kilometers per hour. And then you can transfer your answer to here if you wish to do so. Okay, excuse me. On the return journey from Palermo to Budapest, the journey time is actually shorter, even though the engine thrust is the same. Suggests what might have caused the journey to be shorter. There's a few possibilities for this part. I'm gonna type because my handwriting is not so good. It's possible that there was a tailwind in the return journey, which means there was a wind behind the aircraft making the aircraft moving faster. Or that could have been a headwind on the outward journey, making it going a little slower on the outward journey. It's possible that the pilot has chosen a shorter route on the return journey. Another possibility is that on the way back there were less passengers and the aircraft could have been lighter, so we can say here, or less mass on the way back. So those are possibilities. All of those, it's only 1 mark, okay? You can see here it's only 1 mark, but any of those would do the trick for you and it would help you get your mark. Okay, second question says that in a laboratory experiment to find the center of mass of a triangular piece of card, the card is suspended from the point A, which is here, and then from the point B as shown in the figures. Okay, when suspended from A and D, when suspended from A, point D is found to be vertically below A. So you can see this line here, we find point D. When suspended from B, point E is found to be vertically below B. What piece of equipment or apparatus might be used to determine the vertical lines through A and B? So, I mean, there's a couple of different apparatus that could be used. Okay, so you could use a string, or you could use a plumb line. plumb line. Or you could also use, I mean, if you don't remember the name, something, if you describe what a string or a plumb line is, that would be fine too. Or you can use a tri-square and horizontal bench. Or you could use as well a spirit level. The spirit level is that thing that whenever your parents are hanging their pictures up at the wall, or whenever somebody is building something, make sure and wants to make sure that that thing is parallel to the ground, there's a little bubble, like a water with bubble inside, and we make sure that the bubble is right in the middle. So that's the spirit level. Okay. If you're not sure exactly what it means, you can put it on Google and find a picture of it. Then 2, on figure 3.3 below, draw construction lines to find the position of the center of mass of the triangular card, and label the point of the center of mass clearly as G. Okay, so what do we need to do here? We need to draw a line joining the points A and D, because this is basically the same card. Okay, so you can see here A and D. We draw this line, and then we draw the line connecting B and E. So let me draw those lines. Let's see if I can do that. Zoom in a little bit more. So A and D, yeah, kind of worked. Move a little bit to the side. Not so good. Let me try one more time. Miss Celery is not very good at doing this. Let me draw a longer line going through A and D. That was even worse. Maybe actually not so bad. And then the other one is connecting B and E. And move these accordingly. All right, guys, I'm gonna just stick to that. It's not perfect. Should have gone through E, okay? But anyway, this intersection point is our center of gravity. If I had a ruler here, I would have done a better job. Is our center of gravity, and the question told us to label this as G. So this is the center of gravity, G. All right, then we move on to the next question. The figure illustrates a toy that always returns to its upright position, whatever position it is put to start with. So on one of the 3 positions of the toy, clearly mark X at a possible position of the center of gravity. I mean, we're gonna have to look at all of them. In this case, it's balanced. And if it is balanced, it means that the center of gravity is above that point. Because like could be along this line, or along this line, or along this line, somewhere here. Because if the center of gravity had been here, this line goes past the base of it that's touching the ground, and then it would bend, it would turn this direction. Likewise, if it had been here, this line is past this point, it would turn this direction. So it must be around the central area, okay? So definitely within the central area. Also, definitely within the bottom part, I would say past this point, yes, somewhere here, within the round part of the toy. So if I were to mark it, I would maybe mark here or here, oopsie, or here. It's the central part, yeah, or here, in a way that anytime you draw that vertical line, you draw with a different color. In this case, it's past our point, it's past this point, meaning that it's going to turn this way. In this case, it's also past this point, meaning that it's going to turn this way. In this case, it's in equilibrium. It's right above the point. It's not going to turn. So those are possible scenarios there for 2B. Question 3. It says, state what is meant by the moment of a force. Moment of a force is basically the turning effect. Turning effect. Sorry, I'm not writing on the line perfectly. Turning effect of a force, which is the ability that the force has to cause an object to turn. We can also say that it's basically the force multiplied by the distance from a hinge or pivot, from hinge or pivot point, a turning point, yeah? Then we have a warehouse worker about to close a large door as shown in the diagram. State with a reason which of the two positions, A or B, will enable him to close the door with the least force. Okay, so the answer there is A. A is the answer. And why is it A? Because there's a larger distance to the hinge. The hinge is here. That's where the door is turning, okay? So from A to the hinge, there's a larger distance than from B to the hinge. Okay, so let me put it in writing in case you need it. So because the distance to the hinge is larger for A. So larger distance causes a larger moment, a larger turning effect. In another occasion, with the door in the position shown, two workers each push the door with the same force at the same time. So let's look at the picture. Two of them are pushing the door with the same force at the same time. One worker pushes at A from the side seen. So basically this guy here is pushing at A. The other worker pushes at B from the other side. However, look, they are applying the same force. Important information. The question is, which way does the door move, if at all? Tick one box. Well, if the forces are the same, the moment caused by the person who is pushing at A will be greater by the moment caused by the person pushing at B in the opposite direction because of the distances to the hinge. Therefore, the door should close. So the answer is that the door closes. Then we move on to the next question. Question 4. A train is passing through a station at constant speed. Constant speed is always important information to highlight. As shown in the figure, the track is horizontal. The engine produces a thrust of 70 newtons, and there is a 25 newtons force opposing the motion due to friction in the wheels. Mark these forces on the diagram using an arrow labeled 70,000 newtons and an arrow labeled 25,000 newtons. So I mean, if the front of the train is here, thrust is the forward force. So these would be my 70,000 newtons force, and the resistance force is 25,000 newtons. I'm going to draw a smaller arrow because this is smaller. 25,000 newtons is the resistive force. Then letter B, the train is traveling at constant speed. So if it's traveling at constant speed, guys, there is no resultant force. Okay, just a quick revision. Newton's second law says that the resultant force is mass times the acceleration. If the speed is constant, it means that it's not changing. Therefore, there's no acceleration. So A is 0 because the speed is constant. If A is 0, I can then say F is the resultant force is mass times A. A is 0, the resultant force is also 0. This doesn't mean that there's no forces. It means that all forces combined will be 0. So the forces are balancing each other out. So there must be another force in this direction as well, so that when I combine this force with the friction, these two together will be 70,000 newtons backwards. And there is a thrust of 70,000 newtons forward, okay? So there is going to be this new force. It just stands for the direction. So the direction is, you can say left, or you can say backwards. Backwards. Calculate the size of this force. As I said, for it to be moving at constant speed, the forces are balanced. There's no acceleration. So these two together will correspond to 70 newtons. So if I label this new force as F, I can say that F plus 25,000 must equal to 70,000, which is the force to the right. And therefore, I'm going to find that F equals to 45,000 newtons. 3, suggest what might be causing this force. The best explanation here would be air resistance, okay? So air resistance, also called air friction or drag. If you want to write drag, that's also fine, or air friction, that's also fine. And these forces are opposing the motion. Okay? C. Excuse me. Once the train has passed the station, the driver increases the engine forward thrust. So it's not going to be 70,000 newtons anymore. It's going to be more than 70,000 newtons. All other forces stay the same. Interesting. What happens to the train? Well, if all other forces remain the same, then there is going to be a resultant force to the right, because combining friction and air resistances, we had 70,000 to the left. Then before we had 70,000 to the right, but if you increase the thrust, we're going to have a new thrust which is greater than 70,000. And if this new thrust is greater than 70,000 newtons, when I combine these two forces now, I'm going to have a resultant force, and my resultant force will be to the right. This is my resultant force, and this equals ma. Resultant force is no longer 0, therefore the acceleration is no longer 0. So I'm right here, the resultant force is not 0 anymore, so the acceleration is also now going to be 0. And if there is an acceleration, the speed will increase. So for this question here, what happens to the train? You can say, there's different possibilities, yeah? You can say, well, it will accelerate, or you can say speed increases, or you can even say that it's going to move faster. And the next one, why does it happen? I just explained to you. It happens because now the forces are unbalanced to the right. To the right. And not tight, to the right. And the train will be subject to an acceleration. Okay? Oh, acceleration. That's better. Great stuff. Okay. Question 5a. State the name that is given to the turning effect of a force. The turning effect of a force is called the moment of a force. Okay. Another name, actually we haven't really talked much about this name, which means the same thing, is torque. So torque is the same thing as the moment of a force. B. We have a farmer and the gate. Well, he's trying to open or close the gate. And this gate has rusty hinges, so the hinges here are a little bit rusty, and they're very stiff. The man opens the gate by pulling on it as shown. After he has passed through the opening, he closes the gate behind him. When closing the gate, the man pulls it at a point halfway along its length. So basically, this is the total length of the gate. And when he closed, he pulled along a point somewhere here, halfway along this length. State two differences between his force when he was closing the gate and his force when he was opening the gate. So when he was opening the gate, he was applying a force close to the end of the gate, so close to the whole length of the gate. When he, actually that's when he was opening, yeah? When he was opening the gate, he was applying a force around here. However, when he was closing the gate, he was applying a force along halfway. So he had to apply a larger force to close than what he had to open, because the distance was less. And the moment of a force, as we know, is the force multiplied by the distance to the rotation point to the hinge. So two differences. One difference is that the forces have opposite directions. Let me type, it's better. The forces have opposite directions. One is to open, the other one is to close. And another difference is that the force to close the gate has to be larger than the force to open the gate. I just explained why. It is halfway, it's closer to the hinge. I hope this is clear. Then C. Oopsie. C. Suggests one way of reducing the force needed to open the gate. Well, the best way is to apply the force as far as possible from the hinge. Okay, so when he closed the gate, he applied his force here. Oopsie, here. Make sure that he applies the force around the end of the hinge, around the end of the gate, increasing the distance from the force to the hinge. Another possibility would be to add some oil to the hinge because the hinge is stiff. Yeah, so by adding oil, the friction in the hinge would be reduced. Another possibility would be to use a new hinge. Yeah, and replace this hinge for a new hinge. I don't think I need to write this one. It's only one mark. So in summary, apply the force further from the hinge, grease the hinge by adding oil to it, or buy new hinges and replacing them. Then we go to question 6. Question 6, we have a piece of stiff cardboard attached to a plank of wood by 2 sticky tape kind of hinges. So the sticky tapes are behaving as hinges. You can turn the piece of cardboard about those hinges, as shown in the figure. The cardboard is to be lifted by a vertical force so that it turns about the hinges, about the sticky tapes. What name do we give to the turning effect of a force? It's the same as last time, isn't it? It is the moment or torque. So the moment of a force or torque. Then the second question, force F is too small. Sorry, force F is to be as small as possible. So if the force F is to be as small as possible, it needs to be applied as far from the hinges as possible. So it needs to apply around the end of the cardboard. Okay. So it said on figure 2.1, show the force F position. Let me just show the force F positioned around here at the end of the cardboard. Force F. Then the left, what is it? Yeah, letter B. A box of matches is balanced on the cardboard as shown in the figure. The left-hand edge of the cardboard is gradually raised. The box does not slide. What will eventually happen to the box of matches if the edge continues to be raised? Well, eventually probably it will flip, right? It will top over, it will fall, okay? Why is that? Because the center of gravity of the box should be around here, yeah? So as long as this line goes through the base, it's not gonna flip, it's not gonna fall. However, once we keep lifting, we're gonna get to a point where this line is going to go past the base. So it will fall, okay? Or any idea of toppling would be accepted. So the idea of toppling. State where the center, I already explained, isn't it? Where the center of mass of the box is positioned when it happens. So it's the idea that the center of mass, the line along the center of mass has gone past the base. So it's above or just beyond the edge of the box. Or we can say, as I said, outside base of box. Is vertically above the edge of the box. Okay, so hopefully that will do. C. Filing cabinets often have a mechanism that prevents more than one drawer being open at one time. Otherwise, they might fall over, right? The figure 2.3 shows a filing cabinet standing on the floor with the middle drawer open. State and explain why it might be dangerous to open the top drawer at the same time. Well, by opening too many drawers, we're actually shifting the center of gravity of our filing cabinets. Let's say that all drawers are closed then we would expect the center of gravity to be roughly around the center of the filing cabinet. But as you open, let's say the initial center of gravity would be around the center. As you open one drawer, the center of gravity might be shifted to the right a little bit. Oops, you can draw that. And the more drawers you open, the more you shift the center of gravity to the right. And if it is past the line where, past the edge here, past the base, then it will fall, okay? So if you want to put these in writing, so it might fall or might topple if too many drawers are opened at the same time, because the line along the center of gravity, I should say the vertical line, oopsie, let me read it again, got confused. It might topple if too many drawers are open at the same time, because the vertical line along the center of gravity goes, or doesn't go through the base of the cabinet. I think that should be fine. Question 7. A spring is hung from a support. A load hung on the spring makes it extend. Describe how you would use a ruler to measure the extension, okay? We were online when we did that, but you actually did this practical using a simulator, if you remember correctly. So you would need to make sure that your ruler is vertical and close to the spring, okay? That's one thing. However, you can see that these questions were 3 marks. You're not going to get full marks just by saying that. You need to add more information. How would you measure? Okay. So you need to, first of all, measure the length before and after the extension, after the load is added. And the extension will be the difference between the two lengths measured. All right. Then we have here a data table. The lengths of the spring are found for loads of various ways. From these lengths, the extensions are calculated. Most of the results are shown in the table. So what do we have here? We have the loads in newtons, we have the length in millimeters, and we have the extensions also in millimeters. So you can see here, when there is no load, the length is 200 millimeters. When we add a load of 1 Newton, this is the new length, meaning that the extension, the difference between these two values, is 20, etc. Calculate the 2 missing values and insert them in the table. How could we do that? For this missing value here, the extension is going to be the length minus the original length. So that's going to be 58 millimeters. And for this one here, the length is going to be the original length plus the extension. So 200 plus 97, that's going to be 297 milliliters. Then we're going to plot the values of the extensions against the load, but do not draw a line yet. So I think there's a space here for us to plot the values. Normally in IGCSE exams, we need to set the scale. We need to number. We need to add numbers to the axis, but this has already been done for us. We also normally need to write down here the name of the quantity as well as its unit, but this has already been done for us as well. So I believe all that we need to do is plot the values, okay? So let's see, easy for extension, yeah, extension. So it's going to be 0, 0, 120, 249. So let me go here, 0, 0, let me make it blue. 120. Oh, it's a bit hard. 249. So 49 is going to be trickier. I can find 50. 50 is here. This should be 48. So it's between these two lines along this one. So I think it's going to be here. So let's mark that. 249. Just put a line. Yeah, that. Then the next point is 358, 479. So 3 is easy to see. The 58 is the one right below 60. So 358. And then 479, so a little bit below 80. Okay. That's not so good. Let me move it up a little bit below 80. Yeah, 479. Then 597 and 118. So 90. So here's 100. So we're gonna have here 98, 96. So it's going to be between this line and this line. Okay, for 4. So no, not for 4, for 5. So it's going to be 597. I believe it's here. Yeah, and 6. What was it? 118. That shouldn't be too hard. That should just be this one. Mizumi, so you can mark a little better. Should be this one here. Oopsie. Yeah. Okay. Right. Oh, it looks so small now. It disappeared. Let's go again. I should do a dot then. Okay. Oh, it disappeared again. Why is it disappearing on me? Because I didn't choose the marker, silly Mr. Lira. Man, that's a difficult point to plot. There you go. Looks good now. This actually looks the best. So I have all my points plotted there. That's what the question 2 asked me to do. Then on 3, it says a mistake was made with one of the length values. State the value of the length is incorrect. Well, if we look there, appears to me that if I were to draw a line, it asked me not to draw a line, but if I were to draw a best fit line, which ones would be off? The one that seems to really be off is this one here, 58, right? So 58 would be incorrect, okay? State the value of length is incorrect, it's 58. But it said length. See, Mr. Lira wrong. 58 is not the length. 58 is the extension. So whenever the extension was 58, the length was 258. So the length was 258. If you had written just 58, you would be wrong because it asked for the length, not for the extension. The graph is showing me the extension. I had to find this 58 and add 200, add it to 200, which is the original value. 4, ignoring the value of 3, draw a best fit line through all your points. Okay, let's see if I can do that. I'll change the color to green. And I'll try to make sure that I have one good best fit line going through my points. I think that's good, mostly. Can I adjust a little bit? No. I think that's the best I can do with my iPad. Yeah, I have, this point is almost at the line, so is this, so it's fine. Complete the following sentences. Within the limits of the experiment, when the load doubles, the extension of the spring also doubles. Whenever we have a linear relationship, whenever it is a straight line relating the quantities, if you double one quantity, you're doubling the other quantity, okay? The straight line graph through the origin shows that the extension and the load are directly proportional. Directly proportional. When one increases, the other one increases at the same rate, directly proportional. If it had been that one increases and the other one decreases, then it would be inversely proportional. But it's not, it's a direct relationship, directly proportional. 8, state what is meant by the moment of a force. We've done that I'm not gonna, I think I can skip this one. It's the turning effect of a force, right? B, a plank balances horizontally a log of wood, which acts as a pivot. A girl sits on the end of the plank and the boy pushes down the other end to keep the plank horizontal, as shown in the figure. What two things can be said about the moment caused by the boy and the girl? Well, I can say that they have the same magnitude. The same magnitude. Why is it the same magnitude? Because the plank is balanced. For the plank to be balanced, this moment and this moment have to be the same in magnitude. However, they have opposite directions. Opposite directions. Okay, so the total moment is 0. There are 4 forces acting on the plank when it is in equilibrium. So 3 of the forces are the weight of the girl, here it is, the weight of the plank, which is probably here in the middle, the force provided by the boy, here it is. Where does the force act? Well, there is contact here at the pivot point between the plank and the trunk, yeah, of the yeah. So there's contact force. So if there is contact force, there should be a reaction force. You can label this as R for reaction force, or you can label this as N for normal force. So it acts at the pivot point. At the pivot point. And what is the direction? The direction is upwards. It's a reaction force, a normal force upwards. And that's it. That's the end of this revision worksheet. I hope you have found this useful. Any questions? Do not hesitate to contact me.